Number 7 of exercise 13.1. A tent is in the shape of a cylinder surmounted by a conical top. A conical top. If the height and diameter of the cylindrical part, if the height and diameter of the cylindrical part are 2.1 meters, and 4 meters respectively. 2.1 meters and 4 meters respectively. And the slant height of the top is, of the top is, slant height of the top is 2.8 meters. 2.8 meters. Find the area of the canvas. Find the area of the canvas. Find the area of the canvas used for making the tent. Used for making the tent. Used for making the tent. Also find the cost of the canvas. Also find the cost of the canvas. Cost of the canvas of the tent at the rate of rupees 500 per meter square. Rupees 500 per meter square. Please write. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 meters and 4 meters respectively, and the slant height of the top is 2.8 meters, find the area of the canvas used for making the tent. Also find the cost of the canvas at the rate of rupees 500 per meter square. So please read the question properly to draw the diagram. Tent is in the shape of cylinder surmounted by a conical top. So two shapes are there. Bottom part is cylinder, and the top is, what is the top, children? Solid in the top, conical top. So cylinder and cone are attached. So you will draw the diagram like this. Cylinder, please draw a cylinder surmounted by a conical top. Like the cylinder surmounted by a conical top means on top of the cylinder there is a cone. Is it clear, this diagram? Cylinder surmounted by a conical top. Cylinder and cone are attached. Now we look at the dimensions. Height and diameter of the cylindrical part. Height of cylindrical part is 2.1 meters only for cylindrical part. Some questions we have to subtract, but here it is not required. Cylindrical part height is 2.1. Diameter is 4. So what will be the radius? If diameter is 4 meters, what will be the radius?
2.
Correct. 2 meters. Half of 4, that is 2 meters. 2 meters. I think it is Jadip, right? Yes, 2 meters. Slant height of the top is 2.8 meters. Slant height L. L means it is here 2.8 meters. Slant height L is 2.8 meters. Radius is also the same. Radius is 2 meters. For cone also the radius is same. Radius is common. Radius is 2 meters. Okay. Now we have to find the area. Yes. It is a tent. Tent means this surface, that dotted part 2 meter marked the separation between cone and the cylinder part is open. So the area of the tent means cloth is there on the side. That area is only the CSA, right? CSA is enough. So here what will be the area of the tent? Area of the tent is always CSA, area of the canvas used for making the tent. So that CSA will be the Jwa. It is CSA of cylinder plus
CSA of cone.
Correct. CSA of cylinder plus CSA of cone. But before that, we have to recollect the formula. CSA of cylinder. Anna, CSA of cylinder, what is the formula? CSA of cylinder. CSA of cylinder, Hannah?
Sir, 2 pi RH.
2 pi RH. So R and H are there. So dimension of cylinder is not a problem. But CSA of cone. Suryansh, CSA of cone.
The CSA of cone is pi RL.
Pi RL. R is there, L is also there. So we don't have to find anything extra. Some questions we had to find out L or H separately, but here it is not required. So we have to write the dimensions first, cylinder and the cone. So please write both the dimensions and then we can find the area. Cylinder. Radius R is equal to, radius R is how much? 4 by 2, half of 4, that is 2 meters. Height H is equal to, Nathan, what is the height of the cylinder?
So this
2.1. Yes. Dejwa by this time completed and send the answer. Very good. Like that, those who finished can send the answer in the chat box. Yes. So now we can write the cone. Cone. Radius R is same, 2 meters. L, slant height of the cone, L. L is 2.8 meters. Now the first part is find the area of the canvas used for making the tent. So you'll write like this, area of the canvas, area of the canvas used for making the tent. For word problems like this, you have to write the steps. Some students simply will start CSA of cylinder plus CSA of cone. So do not write like that. Instead, the proper steps should be written. Area of the canvas used for making the tent is equal to, what is that, children? CSA of cylinder plus CSA of cone. CSA of cylinder, everybody knows the formula. CSA of cylinder is 2 pi RH and CSA of cone is pi RL. We can take a common factor outside. What is the common factor any student can answer?
Pi R.
Pi R we take outside. So we get 2H plus L, 2H plus L. Common factor is not a compulsory step, but if you take common factor, you can easily do. Yes, the final answer. Cost is also correct. Very good. So pi we substitute. Pi is 22 by 7 into radius. Radius is 2 in bracket 2 into 2.1 plus 2.8. Now you have to simplify this. 44 by 7 into 2 into 2.1 is 4.2, right? Plus 2.8. 4.2 plus 2.8 is how much, children? It is 7, right? 7. So we get easily the cancellations and all. So Alina, what is the result of this? What is the area? 44 by 7 into 7 is how much, Alina? Alina, I think could not hear. Emmanuel, what is 44 by 7 into 7? 44. We can cut this 7 and we get the area as 44 centimeters square. 44 centimeters square. Area is 44 centimeters square. Alina, am I audible? Okay, 44 centimeters square is the area. Jaydeep, Srinigesh, Imad, Dejwa, all of you please keep the camera on. Okay, so we got the area as 44. Next, we are going to find out the cost. Cost of making the tent. Cost of making that tent. Yes. For that one, it is written. The rate. Rate is written. Yes, yes.
The unit is
Adya, mic. Yes, yes. Fine. So now we are going to write the rate. It is written, cost of the canvas is rupees 500 per meter square. And one more correction is there. It is not centimeter square because other units are meters. So this is in meter square. This is in meter square. Now, the rate is given. Rate for 1 meter square is given. Rate for 1 meter square is rupees 500. Rupees 500. This is the rate for 1 meter square. We want to find out the rate for 44 meter square. Rate for 44 meter square. How will you find the rate of 44 meter square? Yes. Rate for 44 meter square. How can we find out
So
rate?
500 into 44.
Yes, yes. So rate for 44 meter square. So please write. Jaydeep, are you there in the meeting? Jaydeep?
Yeah, sir, I'm there.
Okay. No problem.
That
So
was
now,
some other.
total cost. Total cost is 44 into rupees 500. Total cost is 44 into rupees 500. Okay, so we have to multiply 44 into rupees 500. Yes, can you multiply this one? 44 into rupees 500. You multiply 44 into 5 and put 2 zeros. Only Dejwa's answer I received. Others also, please multiply and send the answer. Angelina got correct answer. What happened, Rachel? Any doubt? Hannah.
No, sir. I was just saying the answer.
Okay. Hannah, correct answer. Srihari got correct answer. Yes, Andrew already sent, right? Andrew already sent the answer. Yes. Alina got the answer. Reina also got the correct answer. Yes. Arjun, please keep the camera on. Arjun.
Yes, sir.
Okay, camera on. Okay, so Ruben, correct answer. Ruben got correct answer. So the answer is 22,000 rupees. Rupees 22,000. Remaining students got the same, right? Rupees 22,000. This is the answer. Hope you all understood like this. Area of the tent, area of the canvas used for making the tent, all CSAs only. That curved surface is enough. Now we have question number 8. Question number 7 is done. Next is question number 8. Please write. From a solid cylinder, whose height is 2.4 centimeters, whose height is 2.4 centimeters and diameter 1.4 centimeters, comma, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid. To the nearest centimeter square. Find the total surface area of the remaining solid to the nearest centimeter square. All of you please write the question and then read through it. Okay, so let's start. Yes, did you complete writing it?
No, sir.
Please complete. Please write the question and then tell me, then we will start. So hope you all finished writing.
Yes, sir.
From a solid cylinder. So we will draw a solid cylinder. All of you know how to draw the solid cylinder. Please draw a solid cylinder like this, a solid cylinder. From a solid cylinder whose height is 2.4 centimeters. Height 2.4 centimeters, like this. Height is 2.4 centimeters. Diameter 1.4 centimeters. So what will be the radius? Radius is half of 1.4. Half of 1.4 is how much? 0.7 centimeters is the radius. From this, a conical cavity of the same height and diameter is hollowed out. So from this, a conical cavity is hollowed out like this. A conical cavity, this cone is taken out. This cone is taken out. Conical cavity of the same height. Height is same, diameter is the same, is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. So look at the area that we can touch, area that we can see is the total surface area. Yes, what is your opinion about the total surface area that we can see here? We can say the CSA of cylinder, is it? Yes or no? CSA of cylinder we can see. Plus area of bottom of the cylinder, that also we can see. What is area of bottom of the cylinder?
Pi r square.
Correct, pi r square. So CSA of cylinder plus area of bottom of the cylinder. Then one more area we can see as a result of this cone is hollowed out. What is that one more area? Is the CSA of a cone, is it? Look at there, that blue marked region, CSA of cone. CSA of cone also we can touch, we can see. So these three areas we have to add. I repeat, CSA of cylinder, the curved surface area of cylinder plus area of bottom of the cylinder plus Nathan one more area. What is that one more area? CSA of cone, right? That cone is hollowed out. That in CSA of cone we can easily see. But the top part is hollow now. The circle part of cone is hollow now. No need to take that area. So CSA of cone is enough as the last one. So these three areas we are going to add. But when we recollect the formula in CSA of cone, what is CSA of cone formula? CSA of cone? CSA of cone? Pi RL. L is required. We have R and H. We have to find L. Andrew, you know the formula for finding L from R and H of cone. Do you remember?
Equal to root of R square plus H square.
Right. L is equal to root of R square plus H square. So we are going to start. We are going to start like this. Write the dimensions. Please write down the dimensions. Cylinder, first of all, cylinder. Cylinder. The dimensions are radius R is equal to, radius R is 1.4 by 2, that is 0.7 centimeters. Height H is equal to, height H is equal to 2.4 centimeters. Then cone, radius R is same, 0.7 centimeters. Height H is 2.4 centimeters. We have to find slant height L. Slant height L is equal to root of R square plus H square. By Pythagoras relation, L is root of R square plus H square. That is root of 0.7 square plus 2.4 square. Can you calculate this, children? 0.7 square we calculate like this. 7 into 7, 49. And take 2 decimal places to the left side. 0.49 plus 24 into 24 is 576. So this is 5.76. 0.49 plus 5.76. Yes. What is the result of this addition? It is root of
6.25.
6.25. All of you know the square root of 625. It is 25. So what will be the square root of 6.25? Two point
0.25.
No, 2.5. Because 2.5 into 2.5, when you multiply, 2 decimal places will be taken to the left side. So that is 2.5. I repeat, all of you know the square root of 625 as 25. So square root of 6.25 is 2.5. 2.5. Yes, now we are going to find out the area that we can touch. Area that we can touch. So that will be, so this is asked to find the surface area of the remaining solid. Surface area of the remaining solid is equal to surface area of the remaining solid is equal to CSA of cylinder plus area of bottom of the cylinder, area of bottom of cylinder area of bottom of a cylinder plus, yes, plus what we have to add, children, plus CSA of cone, CSA of cone, plus CSA of cone. Now, can you calculate this? CSA of cylinder, everybody knows the formula. Shivesh, what is CSA of cylinder?
2 pi RH.
2 pi r h plus area of bottom of the cylinder, that is area of circle. Reuben, area of circle is area of circle pi r square. It is pi r square. Then CSA of cone. CSA of cone is pi r L. Reuben, area of bottom of cylinder means it is area of circle. Area of circle is pi r square. And CSA of cone is pi r L. Now we can take common factor outside. Pi r is a common factor that we can take outside. So pi r into,
Sir,
yes, please ask.
we can take the TSA of the cylinder and then subtract the
Right, save
circle
answer,
area, right?
save answer you will get, okay?
Okay.
It's the same, nothing wrong in that one, it is the same, okay? So pi r into, pi r if you take outside, then 2h plus r plus L, 2h plus r plus L. Then we substitute. Pi is 22 by 7 into radius. Radius is 0.7 into 2 into 2.4 plus r, radius. What is the radius r? 0.7 plus L. L we got 2.5. L is 2.5. 7 and 0.7 we can cut 0.1. So these two we cut 7 and 0.7, 0.1. Then do the simplification. 4.8 plus 0.7 plus 2.5. So please add them, children. 4.8 plus 0.7 plus 2.5 is how much? You will get an integer. What is that integer?
8.
8. Okay, so then multiply. 22 into 0.8. 22 into 0.8. So you'll be getting the answer now. Yes, Sri Nigesh and Andrew got the correct answer. Others also please multiply. After writing the answer in decimal, we have to write it to the nearest centimeter square. First, write in decimal. Dejwa got to the nearest centimeter square also correct. Reina and Suryansh got the correct answer. So you're getting the answer in decimal 17.6. 17.6 centimeter square. Now to write it to the nearest centimeter square, Hanna and Srihari and Aditya correct answer, but nearest, see how to write nearest. So we put this sign, equivalent to, instead of equal to sign, equivalent to. When the decimal place is more than or equal to 5.5 or more than 0.5, we can add one more number, 1 to that previous integer part. So we write the answer as 18. But if it is 17.4, we write only 17. 17.2, we write only 17. But if it is 17.5 or more, when it is asked like this to write the nearest centimeter square, we can write it is equivalent to 18 centimeter square. Rachel also got that same answer, 18 centimeter square. Yes, all of you understood this one. Like this, area of bottom is also required. So we can take the area like the CSA of cylinder plus area of bottom of the cylinder, and CSA of cone also we can touch as a result of followed out. Next, one more question is there in this exercise 13.1. 13.1 is so easy exercise for all of you, I hope. Areas. Next, one more question of 13.1. Please write. Question number 9. A wooden article was made by scooping out a wooden article was made by scooping out a hemisphere from each end of a solid cylinder. Each end of a solid cylinder. If the height of the cylinder is 10 centimeters and its base is of radius, and its base is of radius 3.5 centimeters, 3.5 centimeters, find the total surface area of the article. Find the total surface area of the article. Find the total surface area of the article. Please write. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. So we will draw a solid cylinder like the solid cylinder. And hemispheres are scooped out from each end of the solid cylinder. Last question. cone was hollowed out, but here hemispheres are scooped out. So like this, two hemispheres are scooped out. Here one hemisphere. Here also one hemisphere. These hemispheres are scooped out. Okay, from each end, these hemispheres are taken out. Like this hemisphere is scooped out. And bottom also a hemisphere is scooped out. So from the top of the cylinder, a hemisphere is scooped out. From the bottom of the cylinder also, a hemisphere is scooped out like this. Please draw the diagram. Here also we have to find the total surface area of the article. The surface area that we can touch is. What are the surface areas that we can touch here? We can touch the CSA of cylinder, right? So CSA of cylinder plus two more areas we have to add, same as there in the last one is. What are the two more areas to be added? CSA of cylinder plus
CSA of hemisphere.
correct. CSA of bottom hemisphere plus CSA of top hemisphere. So that CSAs we can touch after the result of scooped out. CSA of hemisphere we can touch. So CSA of two hemispheres we can write together. So this is the area. CSA of cylinder plus CSA of two hemispheres. CSA of cylinder plus CSA of two hemispheres. So we can write the dimensions like this. Height of the cylinder is 10 centimeters. Height is 10 centimeters. Height is 10 centimeters. Radius of the base is 3.5 centimeters. Radius of the base is 3.5 centimeters. Height is 10 centimeters and radius of the base is 3.5 centimeters. Radius of the base 3.5 centimeters. Please complete the diagram. Okay, so then we start writing the dimensions. Cylinder. Radius and height are there. Radius R is equal to 3.5 centimeters. 3.5 can be taken as 7/2 if required. Okay, we'll check the calculation and we'll take accordingly. Then height H is equal to 10 centimeters. Then cone, radius R is equal to, sorry, not cone, hemisphere. Hemisphere, radius R is 3.5 centimeters. For hemisphere, radius R is equal to 3.5 centimeters. Radius R is 3.5 centimeters. Radius R is 3.5 centimeters. Yes. Or 7/2, 3.5 or 7/2 centimeters. Now we are going to find out the surface area of the article. So total surface area of the article is equal to surface area of the article is equal to CSA of cylinder plus CSA of two hemispheres. CSA of cylinder is What is CSA of cylinder? 2 pi RH. 2 pi RH plus 2 times CSA of hemisphere is 2 pi R square. 2 times 2 pi R square. We can take 2 pi R outside. 2 pi R into H plus 2R. Now can you substitute and simplify 2 pi R into H by 2R? So please try to simplify this one. 2 pi R into H by 2R. That is 2 into 22 by 7 into radius. Radius is 3.5. That we can write 7 by 2 into H plus 10 plus 2 into 3.5. So we can cut 7, then 2. So 22 into 10 plus 7, which means 22 into 17. Multiply, children. 22 into 17, you will be getting the answer. Andrew, correct answer. Sri Nigesh, check the answer again. Dejwa got correct answer. Other children, please multiply and send the answer in the chat box. Yes, please keep the camera on, remaining students on. Unmute the video yourself and attend the class. Yes. Hannah Maria, correct answer. Aditya, Imad, Srihari, Angelina. These children also got correct answer. Ruben Matthew, correct answer. Glanston, correct answer. What about Nathan? Suryansh got correct answer. Shivesh also got. So majority of you got 374 centimeter square is the answer. 374 centimeter square. 374. So hope you all understood these sums. Next, from the work dot example, question number 4. Example number 4 we are going to do before starting the second exercise, volume exercise. Work dot example, example number 4. As I told you, example number 2 is a similar question of question number 4 and 5 of 13.1 exercise. Now we are going to do that question number 4. Please write. Example, work out example number 4 of NCERT. Mayank, M-A-Y-A-N-K, Mayank made a bird bath for his garden. In the shape of a cylinder. In the shape of a cylinder. With a hemispherical depression at one end. With a hemispherical depression at one end. The height of the cylinder is 1.45 meters, 1.45 meters, and its radius is 1 30 centimeters, 30 centimeters. Find the total surface area. Find the total surface area. Find the total surface area of the bird bath. Find the total surface area of the bird bath. So diagram is given in the textbook, but we will draw that one. In case if it is not given also, you should be able to draw that one. So here, what are the solids? Shape of a cylinder. Bed bath shape is in the form of a cylinder with a hemispherical depression at one end. So we'll draw a cylinder. Like this, a cylinder with a hemispherical depression at one end. Hemispherical depression at one end, like this. Hemispherical depression. Hemisphere is hollowed out at one end. Here the bottom part will be hollow. Bed bath means that the bottom part will be hollow. Water will be filled in this hemispherical depression. So water will be here, not at the cylindrical part. Okay, so water will be here, so that birds can use this water. So water is not at the bottom. So bottom part is hollow. So here the area that we can touch is only CSA of cylinder plus what will be there? CSA of
Hemisphere.
hemisphere. That is enough. No need to take area of bottom. So for bird bath, that bottom part will be hollow, but this is closed. That hemispherical part, CSA part will be closed. So CSA of cylinder plus CSA of hemisphere is enough. Now we have to write the dimensions. Height of the cylinder is 1.45. Radius is 30. So clearly the dimensions are given. Cylinder for the cylinder, radius R is equal to, radius R is 30 centimeters and height H is equal to 1.45 meters. That is a problem. One is in centimeter, other is in meter. So I just convert this into centimeter. For that, multiply by 100. So that will be 145 centimeter. Okay. So that also very important point. Both the dimensions should be in same unit. If one of them is in centimeter and other is in meter, we just convert like this. Now for hemisphere, radius R is equal to, radius R is 30 centimeters. Radius R is 30 centimeters for the hemisphere. Now we write total surface area of the bird bath is equal to CSA of cylinder plus CSA of hemisphere. Total surface area, of the bird bath is equal to, CSA of cylinder plus CSA of hemisphere. CSA of cylinder plus CSA of hemisphere. CSA of cylinder is 2 pi RH plus CSA of hemisphere is 2 pi R square. 2 pi RH plus 2 pi R square. We can take 2 pi R outside. 2 pi R into H plus R. 2 pi R into H plus R. Yes, now did you substitute and got the answer? Please send the answer in the chat box. So don't leave the meeting in between because I did not take the attendance. Today at the end of this class only I will take the attendance. Okay, all of you have to be there in the meeting. So 2 into 22 by 7 into radius. Radius is 30 into 145 plus 30. 145 plus 30. Simplify. So 2 into 22 by 7 into 30 into 175. 175. 7 and 175 we can cancel. 7 and 175. So what do you get when you cancel 7 and 175? 7 2s are 14. So 3 is the remainder. 35 means 7 5s are. So we get 25. Then multiply the remaining. You will easily get the answer. 2 into 22 into 30 into 25. Again, Dejwa got correct answer. Dejwa, right answer. Sri Nikesh. Aditya Ulla, slight error. Arjun got correct answer. Other students also please multiply. So the answer is 33,000 centimeters square. How many of you got 33,000 centimeters square? In case if the question is asked us to write in meter square, you will divide by 100 into 100. Centimeter square to meter square, divide by 100 into 100. So I will write that in the reference space. Here is it asked there? No, here it is not asked. So the unit is not a problem. But in case if they ask, you will do like this, divide by 100 into 100 to convert centimeter square to meter square. So you will get the 2 zeros will go, one more 0 will go, 3.3 meter square. Centimeter to meter is divided by 100. Centimeter square to meter square divided by 100 into 100. Okay, so like that, you can easily write the units. Example 3, we will discuss at the end of this chapter. Now we are moving to 13.2 exercise, 13.2 based on volume. We have 13.1 and 13.2 only in this chapter. Other 2 exercises are deleted. So these 2 and sums based on these, you have to study thoroughly. Next, 13.2 is fully based on volumes. So let's start. Write the subheading, volume of combination of solids. Subheading, volume of combination of solids. Volume of combination of solids. Combination of solids. Please write the subheading, volume of combination of solids. Subheading, volume of combination of solids. So we have already written all the formula. Volume of cuboid is L into B into H. Volume of cone is, we can also unmute and say volume of cone is AQ, right? AQ. Volume of cylinder. Volume of cylinder.
Pi r square h.
Pi r square h. Volume of cone.
1 by 3 pi r square.
1 by 3 pi r square h. Volume of sphere.
4 by 3
4
pi r
by 3
square.
pi r
Pi
cube.
cube.
Correct. Volume of hemisphere.
2 by 3 pi r cube.
2 by 3 pi r cube. So these formula we use here. Volume. Volume means the amount of liquid that it can hold. That is volume. Surface area means the surface that we can touch. is the surface area. But how much capacity a solid is having, that represents the volume. Okay, how much amount of liquid we can pour into that solid, that will be the measure of volume. Like that, this type of condensed when it is asked, you will do volume. So please start questions based on exercise 13.2. Exercise 13.2. Question number 1. A solid is in the shape of a cone. A solid is in the shape of a cone. Is in the shape of a cone, standing on a hemisphere. Standing on a hemisphere. Standing on a hemisphere with both their radii being equal to. With both their radii being equal to. With both their radii being equal to 1 centimeter, 1 centimeter, and the height of the cone is equal to its radius, and the height of the cone, is equal to its radius, is equal to its radius. Find the volume of the solid. Find the volume of the solid. In terms of pi. In terms of pi. Find the volume of the solid in terms of pi. So please write this question. Okay, solid is in the shape of a cone standing on a hemisphere. So we have to draw hemisphere down. On top of that, there is a cone. So cone and hemisphere. Hemisphere. Then cone standing on a hemisphere like this. Cone standing on hemisphere. This is the shape of the solid. Solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. So this is 1 centimeter. Here also it is 1 centimeter. Both their radii is 1 centimeter. And the height of the cone is equal to radius. So what will be the height of the cone? This part, height of the cone, that is also 1 centimeter. Height of the cone is equal to radius. We have to find the volume. So volumes are easy as compared to area calculation. Volume is the total volume only. We have to add the volumes of the two solids. So it is volume of hemisphere plus volume of cone. Everybody knows the formula. Volume of hemisphere, you know, and volume of cone also, you know. So please write the dimensions. All of you, please write down the dimensions and then you start. You have to write the answer in terms of pi here. So here, for the cone, first I write cone, radius r is equal to 1 centimeter. Height h is also same 1 centimeter for the cone. For hemisphere, radius r is 1 centimeter. Hemisphere, radius r is 1 centimeter. Hemisphere, radius r is 1 centimeter. Then we have to write volume of the solid. Volume of the solid is equal to volume of the solid is equal to volume of a hemisphere plus volume of cone. Volume of hemisphere plus volume of cone. Then substitute, children. Answer, Andrew, correct answer. Dejwa got correct answer. All of you, please try this one, easy calculation. Volume of hemisphere, everybody knows. 2 by 3 pi r cube. Volume of cone. What is volume of cone? 1 by 3 pi r square h. So 2 by 3 pi into 1 cube plus 1 by 3 pi into 1 square into 1. Simplify. 2 by 3 pi into 1 cube is 2 by 3 pi plus 1 by 3 pi. So 2 pi plus 1 pi by 3. So that is 3 pi by 3, that is equal to pi centimeter cube. Answer is pi centimeter cube. So this is the complete answer to this question. Answer is in terms of pi, so pi centimeter cube. Done. Next, question number 2. Question number 1 is done. Next is question number 2. Rachel, an engineering student, Rachel, an engineering student, was asked to make a model. Was asked to make a model shaped like a cylinder. Shaped like a cylinder with the 2 cones attached at its 2 ends. With 2 cones attached at its 2 ends. With the 2 cones attached at its 2 ends by using a thin aluminum sheet. By using a thin aluminum sheet. by using a thin aluminum sheet. The diameter of the model is 3 centimeters. The diameter of the model is 3 centimeters and its length is 12 centimeters and its length is 12 centimeters. If each cone has a height of 2 centimeters, if each cone has a height of 2 centimeters, find the volume of air. Find the volume of air contained in the model. Contained in the model. Contained in the model that Rachel made. That Rachel made. Find the volume of air contained in the model that Rachel made. All right, children, so please write this question. Rachel, an engineering student, was asked to make a model shaped like a cylinder with the 2 cones attached at its 2 ends. So cylinder, you will draw the diagram like the cylinder with how many cones attached at its 2 ends? Cylinder with 2 cones attached at its 2 ends. Like this, a cylinder and 2 cones. One of the cones will be here and the second is here. 2 cones attached at its 2 ends. This is the shape of the model. Cylinder with the 2 cones attached at its 2 ends. Dimensions are given. The diameter is 3 centimeters. So the radius will be 1.5. Radius is 1.5 centimeter. Radius is 1.5 centimeter. Length is 12 centimeter. Total length is 12 centimeter. Length means it is the total length, 12 centimeter. Then, each cone has a height of 2 centimeter. Height of the cone is 2 centimeter. So we have to write the height of the cylinder. What will be the height of the cylinder? If this 2 and 2, 12 minus of 2 plus 2, 12 minus 4, that will be 8 centimeter will be the height of the cone. Now we can easily find out volume of air means the total volume is enough. Means volume of cylinder plus volume of how many cones? Volume of cylinder plus volume of 2 cones, right? So you know about the formula. So please write the dimensions and then substitute in the formula and find out the volume, the total volume. Okay, so did you complete the diagram? All of you finished till here? Yes, done. Now we write the dimensions. Right. Cylinder. Radius R is equal to 3 by 2, that is 1.5 centimeters. Height H is equal to, I will write capital H for cylinder because the heights are different. Height capital H is 12 minus of 2 plus 2. That is 12 minus 4, 8 centimeter is the height of the cylinder. Next, cone. Radius is same, 1.5 centimeter. Height h is equal to what is that? Height h 2 centimeters. Height h is 2 centimeters. Then we write total volume. Total volume is equal to volume of cylinder plus volume of two cones. Volume of cylinder is pi r square h plus 2 times volume of cone is 1 by 3 pi r square h. Pi r square h plus 2 times 1 by 3 pi r square h. Then substitute. That is pi r square into 2 by 3 pi r square is taken outside. So 2 by 3h, 2 by 3h. Now please substitute. Pi r square is taken outside. All of you understood the substitution. Capital H and small h are different. When the dimensions are different, we have to use like this, different letters. Okay, otherwise we may get confused when we take the common factor outside. Here only pi r square is common factor. Now we substitute. Pi is 22 by 7. Into radius. Radius is 1.5 into 1.5 or 3 by 2 into 3 by 2 also we can put, which is easy for simplification. Accordingly, you can write. Okay, 3 by 2 into 3 by 2 is also not a problem. Like this, 3 by 2 into 3 by 2 into capital H. Capital H is 8 plus 2 by 3 into 2. Now we can simplify. 2 and 12 we cut. Sorry, 2 and 22 we cut 11. So 11 by 7 into 9 by 2 into 8 plus 4 by 3. 4 by 3. Or 11 by 7 into 9 by 2 into 24 plus 4 by 3. Or we get 11 by 7 into 9 by 2 into 28 by 3. 28 by 3. Now we cancel out this 3 and 9. It is 3. 7 and 28 also we can cut. 4. Now 2 and 4 we cut. Or we get like this, 11 into 3 into 4 by 2. Now we get a perfect integer. The complete answer to this question. So I will take the attendance now. After that, we will wind up this session and everyone practice. Everybody have to practice by tomorrow. Before attending the class, you have to practice this topic also very well.